Well, how are you doing? Okay, this is going to be an interesting video. I'm going to do my best to keep it as short as possible, but also give as much detail as possible. Okay, in my last video, I made a video about LIGO and how uh, this side length here, how there was this, that should have been shorter if because LIGO is a right angle triangle. Sorry, is at a right angle, it's perpendicular, and both arms of the LIGO station are straight horizontals. They have to be because they're shooting lasers through them, right? They have to be horizontals. They're both 2.5 miles in length, and so this side length here, when I did the calculations with a right triangle calculator, this side length here uh, absolutely matched the surface distance, proving that it wasn't a chord length, proving that it was a surface length, proving that it's a straight line, proving that there was no such thing as the globe and no curvature. So this time I'm going one better. Okay, this is what I'm after doing. I took a distance from the intersection point down here, right? Now, the last one I need to be extra precise. This one, not so much. You'll see why. And I measured a distance to this location up here. Show you now. It's Abbotsford. It's just in past just over the Canadian border, Mill Lake Park, right? I just showed you, right? So the distance was 224.28 miles, and the heading was 324.10 degrees. So that's how I held the line. I held the line by holding the heading, right? Once I hold the heading, that starts at that straight line arm of the LIGO station. I'm holding the heading. So I measured 224.28 miles, as I said, and the heading is 324.10 degrees, right? So then what I did is I came to the polygon and I measured from the LIGO station. I'll show you that. This stuff always happens faster when you're not on video. From the LIGO station up to here, okay, back down to the other arm of the LIGO station, which we know is 2.5 miles. Sorry, between here and here, right? And that all came to 451.07 miles, right, as its perimeter. So 451.07 miles, right, is the perimeter. So if we, right, take the take the calculator and we put in our length of both sides. So you have our length is 224.28, if I remember correctly, 224.28. And that's the length of one side, which is this one here. Then we put in the length of this side, which is 2.5. So we are going to plus 2.5, right? Equals 226.78. So that's the length of both of those sides from this side and this side. Now, this is the thing before I move on. This doesn't need to be exactly precise, but it needs to be precise enough. Because the whole point of this is that we're using a right angle, right? So there can be no claims of curved lines simply because we're using a right angle. So they can't be curved lines and straight lines. They don't match together. They either have to be straight or they have to be curved. So this can't be, right, which I'll show in a moment. This can't be what they're trying to claim to be a spherical triangle, which there's no such thing as. But it's a mathematical thing, right? There's no such thing in reality measured like. So these two sides together are 226.78 miles, right? So I'm just going to copy that, right? I'm going to press C, and I'm going to put in the full total length of 451.07, right? Then I'm going to subtract our two sides, edit, paste, right? And that will leave us with the length of the other side, right? 224.29, right? That's the length of the other side, right? So we know the length of the other side and we know the length of this side. And they're both from the two sides, they're both from, obviously one from here and one from here, right? So, but this side here is technically going to be the length of side we need to find out for, solve for, right? So come into the triangle calculator, we have our first side in, right, 224.28, and we put in our second side, which is 2.5, right, 2.5, 224.3. So our calculator said 224.29, right? So it's very, very close. So the point is that both those sides, this side here is the side we solve for, and that is the actual distance in straight lines. So for those who may not be fully aware what is he talking about, right? This length here, sorry, I'll just go back in so you can see it. It's pretty shallow. This length here, this side length here, has to be a chord line, right? On a globe, if we lived on a globe, that can only be a chord line. It can't be a straight line because I'm using a right angle triangle and I'm solving for the right angle triangle. So that can't be a curved line. It can only be a straight line because you can't have a right angle triangle and curved lines. They don't work together. You can only have one or the other. That's the point. So this line here, using trigonometry, as I just showed, has to be a chord length through a circle, chord length through the globe. But I've just shown, which would mean that this length here that I've just calculated for, right, this other length here that comes down to the other arm here, that has to be a lot shorter than the actual distance, right, over the surface if we were on a globe, because that's a chord length which would be shorter than the arc distance that's over it. But it just showed and proved that it's exactly what it should be using triangulation. Or sorry, trigonometry, not triangulation, trigonometry, using the right angle triangle solving for it. So that is, we're now at 7 minutes and 15 seconds of a video. I don't think there's any need to go further. We can do this in many ways, many directions. There's also the other LIGO, the other LIGO station. I can do it there as well. The point is that I'm solving for a side that has to be a chord length. It can't be the surface distance. It has to be a chord length within your model, but it's within your model, and it is a chord length. But it has to be a chord length if we lived on a globe, right? Because the surface distance has to be an arc, which has to be greater. But I just showed that the actual surface distance matches the straight line side of a right angle triangle. I don't see any way out of this for them. There is no way out. It's absolutely the end. Thank you.